We are on Unit 3 now, and our first lesson's topic is piecewise functions. So let's define it first. A piecewise function is made up of two or more functions. Obviously that means function. Okay. Each with its own domain. Okay. And so we're going to first evaluate piecewise functions. So plug in a value for x. Okay. And if you look at the first example, we have two parts excuse me, of the function. So if your x is less than -2, then the function is going to be x squared minus 1. If your x is greater than or equal to -2, then your function is going to be 5x plus 3. So when you're asked to evaluate, you need to pick the correct function based on the x you're given. So we want f of -5. That's an x value, okay? Where does -5 fall? In less than -2 or greater than or equal to -2? Okay, that's obviously less than -2. So we're going to use the function x squared minus 1 because it's less than -2. It's going to fall in that part of the piecewise function. So now f of -5 is going to be -5 squared minus 1, which is 25 minus 1, 24. Okay? Now, f of -2 is probably the trickiest one because our domains are defined at -2, either greater than or less than. But if I'm actually given -2, then I want the one that has the equals to, okay? So I'm going to have to choose 5x plus 3 for part B. So the function we're using here is f of x equals 5x plus 3 because I need to have it equals to, because I'm asked an x of -2, okay? So now I'm going to plug in -2 and put that right in your calculator, and f of -2 will be -7. Okay, that'd be -10 plus 3, -7. All right, and last one is f of 7, so that's going to fall in the same equation because we're at greater than or equal to -2. So the function I'm using here is 5x plus 3. So f of 7 will be 5 times 7 plus 3. That's 35 plus 3, 38. Okay? All right, part 2 is the same. We have 3 different chunks of our domain now though, okay? So if I'm given something that is less than or equal to -4, I'm going to use 1/2 x plus 3. If I'm given something between -4 and 1 but not equal to, I'm going to use -x minus 1. And if I'm given something greater than or equal to 1, then I will use 2x to the 3rd power plus 9 for my function. Okay, so g of 2 falls in greater than or equal to -1. So the function we're using here is 2x to the 3rd power plus 9. So g of 2 will equal 2 times 2 cubed plus 9. All right, that's 2 times 8 plus 9. Okay, so g of 2 will be 25. All right, now g of negative 1 is going to fall in between negative 4 and 1. So the function I'm using is negative x minus 1, okay? So then I'm going to plug in negative 1. G of negative 1 is negative 1 minus 1, which is 1 minus 1. So g of negative 1 is 0. Okay, and finally g of negative 6 is going to be our 1/2 x plus 3, because that's less than negative 4. Less than or equal to negative 4. And sorry, I didn't rewrite the function, I just went ahead and plugged it in, but you should be able to follow that. So that would be negative 3 plus 3. G of negative 6 is also 0. Okay? All right, so that was evaluating, and now we're going to talk about graphing these functions. Okay, so basically you have to split your graph into, it helps if you have two colors, an area that's less than or equal to negative 3 on the x, and an area that is greater than negative 3 on the x, okay? So, and this will be pretty colorful for a couple of examples till we get it. But negative 3 on the x, negative 3 is over here. So basically, if I'm less than that or equal to that, I'm going to have a certain graph here, which in this case it's x, so we'll graph that, okay? And then if I'm greater than negative 3, so on the right side of it, I'm going to have a totally different graph, okay? So it's going to look like two different chunks of two different lines, all put together on one graph, okay? And we're going to have to graph both of them. So remember, f of x is y equals, that's another word. So for x is less than or equal to negative 3, my graph is y equals x, okay? So what you want to do is, that is a slope of 1 over 1 and a b of 0, okay? So what I suggest is that you plot all of these points the whole way across the graph, but we're only going to connect the domain, the left side, because that's what the domain is here, less than or equal to negative 3, okay? So, let's do b of 0, and our slope is up 1 over 1. So I'm putting all these dots, and I'm also going to reverse it. So go to down 1, left 1. Make sure you're reversing both ways, okay? And I'm only going to actually connect the left side, because on the right side my graph is something else, okay? And then you have to think about this greater than or equal to negative 3 means I need a closed circle on negative 3, okay? So let me focus. There. So I have one line on the left side, and then on the right side, I'm going to have a totally different line, okay? And then this one was closed because of equal to, so whatever value that is, I'm closing it. Then the blue one will be open, okay? So let me graph that with a different color. I'm going to have y equals negative 2x plus 1 for x is greater than negative 3, okay? And that'll be a totally different line. So, this is a slope of down 2, right 1, and a b of 1, okay? So again, I'm going to plot my dots, but I'm only going to connect the blue side. So negative 2x plus 1, I'm going to start at 1 and go down to right 1, down to right 1, okay? I'm going to go up to left 1, reverse both ways until you've hit your border, okay? Oops, I probably shouldn't have done that, because right here I need to have a open circle at negative 3. And then I'm going to connect everything, okay? So that is your piecewise graph, and I'll show you here without all the coloring, okay? So here's -3. On the line y equals x, we have a closed, and then on the line y equals -2x plus 1, we have an open, okay? And I've connected only the sides according to the domain. All right, so let's talk about the domain and range of the piecewise function, okay? So if you have no hole in your graph, then your domain is all real. So even though I have a hole up here, there's a value down here that closes it up. So I do have a value for every single x, even though it jumps. We'll talk about that later. But there is a domain of all real numbers, okay? All right, and our range, well, there's a clear y value up here that the graph does not go under, or go above, excuse me. And that is a y of 7, okay? For all other y's, there is either one value or even two values, okay? So it's gonna be below 7 and open circle, okay? So that's a y is less than 7, okay? Open circle at 7, and the rest of the graph is going below it. All right. There's a lot of examples, so I'm gonna go ahead and just do the odds. You can try the evens if you want. And don't forget y equals -5, that's gonna be a HOI. Okay, so let me move on so this video doesn't get super long.